essentially what I'm going to do is show you some Canvas type stuff, some effects that you can create. Then I'm going to show you some other effects that you can create with SVG. I'll show you some audio stuff that you can do with Canvas. I'll show you a little bit of video that you can do. And some of them you probably haven't seen before, some of the types of samples of things that you can do. And I guess the main thing is that probably as I've said, I always say, no sane person would use my code in a production website. The intent is to show you the functionality and the capabilities, and then you take that very small sliver, subset of functionality that's relevant for you. I'm not a designer. How many people are? Okay, one thing I do know about design is those nice effects that you create at the beginning that people love, the first, second, third time, by the 10th time they're sick of it, right? So that moderation, almost subliminal kind of thing, I don't have anything subliminal, trust me. So, but it's possible to get if you've got the right pieces, parts. So with that in mind, how many people are web developers? Okay, so good. You're here because you want to learn about Canvas. And let's get started. This is as bright as I can get this, by the way. I don't know why. It looks a lot nicer on my laptop, but I don't know what. Is it the lighting? Okay, so excuse me. What is HTML5 Canvas? It's an element. In some ways, you can treat it as any other element that you put on a web page. You know, button, list, whatever. Except that a Canvas element is actually a bitmap, stuff that you can write on. And you can also read from it as well, although that's less common when people are manipulating Canvas. So there's a set of JavaScript-based APIs that you can use to manipulate the canvas. It's one of those, the various descriptions is there's direct mode, it's called fire and forget, Etch-a-Sketch. When you create something, you write in it, it's done. There's no additional history involved in what you did. If you wanted to, for example, a paint program, if you wanted to keep track, you know the undo feature? You would have to create a list of the events that took place, of the things that happened, so that you can do the undo. That's the consequence of this kind of fire and forget mechanism. Other things that are DOM-based, like SVG, Silverlight, are not bitmaps. They're elements that exist somewhere in the DOM structure. Now, of course, when do you use which one? And what about performance? And so on and so forth. Those are the questions that come up. There's no kind of clear answer in terms of, it's a spectrum, if you will. In some cases, it's very advantageous to use SVG, for example. In other cases, it's more advantageous to use Canvas. And sometimes it's sort of in between. Generally speaking, if you've got lots and lots of small things moving around rapidly on the screen, think games, probably Canvas. And if you look around, you'll probably notice that, well, compare the number of HTML5 Canvas books that have been written in the last, say, 3 or 4 years, having to do with sort of game development, and count the number of SVG books that do the same. The latter, I think, is probably 0. Or you might find a book that has a few chapters in that. So the preponderance of what's out there kind of suggests that there's a reason for that. So DOM is for larger type, fewer elements, not a lot of activity going on, even though transforms are supported. You can manipulate elements, you can create animation effects, but think about it. If you're writing something in the DOM into a bitmap, it's going to be a lot faster to do that than it is through JavaScript to manipulate a DOM, right? That's always the kind of a bottleneck. So it's kind of intuitive that that would be the case. So what kinds of things can you create with a Canvas element? The usual 2D, excuse me, HTML Canvas, by the way, is 2D, as is Silverlight and SVG. And, excuse me, I bring that up because CSS3, which I'm going to show you how to work with Canvas stuff, CSS3 provides 3D graphics animation effects. None of the other technologies provide that. You have to go to something like WebGL. which uses another language, C-like language as a whole. It's painful if you're not in that mindset. So it's an interesting thing where there's a tremendous amount of power available in CSS3, and that what attracted me was that capability and the fact that you could do graphics, which is what I like doing in SVG and all the rest. And you can do it in CSS3. It's not imperative coding. It's not declarative like with SVG. It's just value, property, value. So almost like a, just a list of name value pairs, like a hash table, sort of. So it's very expressive and it can be very compact. So it's kind of, in some loose sense, it's more declarative-ish than it is imperative. So anyway, so as far as the 2D shapes, what can you do? Typically, line segment, rectangle, square, parallelogram, quadrilateral, all the four-sided, but actually polygons in general, circles, ellipses, arcs, Bezier curves, quadratic, cubic, and there's also the ability to create basically arbitrary shapes using this path element, where you can concatenate, that was a little hard to say, you can concatenate a variety of elements, so you could have a segment, an arc, a curve, and so on and so forth. In addition, all of the things that, all the technologies that I mentioned support all of that, except for the Bezier polygons in CSS3. The other thing you can do in all of them is linear gradients and radial gradients. And you can apply transforms, and typically they are translate, which is moving horizontally, vertically, rotate, so it's that, skew, which is this way or this way, and then scaling. You can also create animation effects based on using the transforms, and that's where they kind of have a different way of doing it. As I mentioned, with Canvas, there are JavaScript-based APIs. So, whereas in SVG, it's an XML-based construction, and XML can be sort of heavyweight compared to something like JSON. And then when you can really see that when you start doing, like, declaring the animation, it just gets really unwieldy. So that's not so much fun. It's not too bad, actually, with Canvas, or with, say, something like Silverlight. And, of course, with CSS3, that's the best. So that's kind of the sort of what you can do, some of the similarities and some of the differences. So let's take a look. Oh, before I go on, one important thing, the last point there. Actually, RIM, their playbook, last year provided hardware acceleration for Canvas. I think there's one other tablet that provides hardware acceleration for Canvas, whereas at this point in time, as far as I know, no hardware acceleration for SVG, although I heard some companies working on it. And of course, CSS3 does have hardware acceleration on most platforms, apparently. I think most platforms. You can go to Can I Use, I think you'll get that information. And there's a little sort of one thing to mention, because I'm not going to show you that code. Generally, when you use 3D transforms, which are the counterpart of the 2D transforms, generally what will happen is the browser will detect this and then get the GPU involved. But it's not guaranteed. There's a technique for making sure that you get hardware acceleration. And the absence of that doesn't mean you won't get it, it's just not guaranteed. And this translate 3D 000 is essentially like a no-op, where nothing is done, but it effectively ensures that you get hardware acceleration. So that's another factor. I mention these things because the individual technologies you can also combine them in different ways to try to leverage their strengths and get something that is performant. But you need to be aware of some of the limitations, and also, of course, ultimately, you need to test whatever application you're running if you want to cross, as always, right? You have to do that on multiple platforms. So, back to the code samples. So this is Canvas. It's a set of circular arcs, and it just uses a little bit of code, sort of kind of, when it goes alternating bands, it changes the size and the radius of the arc. I'm not going to go into too much of the syntax of the individual JavaScript APIs, time-wise, we wouldn't get through everything. So, and then it has a filtering effect that you can create. This is probably about a page of code to create something like that. Oops. So, another, oops. This is weird the way it refreshes. Somehow, for some reason, when this is connected to that, weird things happen. Okay, so here's an example where the reddish blobby things, whatever they are. This is the CSS3 selector. This is the canvas element. Now, it might seem odd or strange to do something like that, but when you consider this, what do CSS selectors do? They match elements on an HTML page, and then they apply whatever transforms you've defined in the selector, right? Well, canvas is just another element that's on an HTML page. So you can obviously have a selector that matches that. You can apply effects to that, just like you can with anything else. Now, I'm not sure if you can see this. Okay, so when I do a hover over, I get the, see, like I said, nothing subtle about my samples. Now, down below, unfortunately I can't see it too well. What do you think that is up there? It's actually line segments. So on the left side, these are just line segments, and then there's a manually constructed gradient effect. So it's not a built-in gradient. You just change the RGB component, where the G and the B are 0, and R goes from 0 to 255. So 0 would be black, or the other way around, 255 to 0 actually. But instead of going from black down to red, or red to black, it does it in every alternate smaller sections like that. That's the only difference. And then this one sets the RNG, and the blue is 0. And this one, the RNG is 0, and the blue is set. So it's actually very efficient, because line segments are real easy to using the built-in line function. And then when you click on this, can you see? Unfortunately, it's not coming out too well. So it's creating kind of a 3D effect, right? And trust me, I'm one of the laziest people I know, so I always want to find the simplest way to create the effect. And the key idea is actually very simple. Typically, when you're doing games type development movement, you redraw the screen, you refresh, you wipe out what's there, because then you have to move something on the screen. Or what you have to do, it's kind of like with browsers where they do the repaint, reflow. There's certain sections. You can trigger an entire page reflow and a repaint, or you could do certain portions of it. Now, that gets more intense for performance. What this I'm doing here is simply not clearing the screen. So when I draw the initial one, when you click down here, it takes that upper corner over there, which is sort of the starting point for everything, adds 1 to the X value and adds 1 to the Y value. So what it does is it shifts it diagonally. That's it. Now, you can go up and down, left or right, whatever you want. You can have a sine wave, for example, some trigonometric function, and have that determine how you, whatever it is that you want. But the key idea basically is the same. So you can create very simple, using very simple code, you can create some kind of unusual effects. So, what's next? Oops. Okay, so this one, here's the animation. Uses CSS3. If you weren't here this morning, previous session, CSS selectors have something called a keyframe. In the keyframe, you specify things that happen as a percentage from the beginning to the end, and then they do the various transforms to the matching elements. So in this case, it's just doing some rotation stuff and changing the color of the background. Now, again, down here, a similar idea. You know, I wish you could see what I'm seeing here, because it looks a lot nicer than what's there. Next one is another example, just of rendering techniques. These are line segments. And essentially, what happens is they go from here, and then as you increase, it drops down and slides that way. And then it uses that shading effect technique that I was talking about. This one is an ellipse, and it calculates the points on the ellipse, and then it goes around radially, and then calculates that same effect. So it's all line segments in there. It's very efficient. If you need to draw something like that, you can get some techniques from that. And what else? Text is probably, wow, it's refreshing. Why is it taking, okay. So here you can have, again, a similar, kind of a vivid example of, again, if you want to, this is drawn on a canvas element. If you want to have, it's a little bit kind of busy here, so you can always clear the screen first and pretend that you do the redraw, whatever variation that you want. So it's not just geometric objects, but you can render text as well. That's a little bit too wild. And little Bezier stuff with animation effect. Again, without redrawing the entire screen, just sort of overlaying. And enough of that. This is where you can get mouse. Wow, this is weird. This is not quite what it's supposed to look like. But essentially, you can detect mouse events on that canvas, and then you can do whatever it is you want to do, rendering new shapes and so forth. And okay, so that takes care of most of the shapes that I was talking about with Canvas, and with a little bit of a twist, a little bit of CSS that you can use. And I want to show you a little bit more. So that brings us, John, to SVG. I already talked about that. A couple of points. It's available for sure on Ice Cream Sandwich. I know because my samples all work on that. Before version 4, like version 3 and earlier, limited support for SVG on tablets. For iOS, it works great on an iPad 3. I think it also works really well on iPad 2. I haven't tested that. That link is a very good link of an article written by Patrick Dingler. He's a product manager at Microsoft. It's a couple years old. You want to read this if you want to know about when to use SVG versus Canvas. It's got diagrams there about where it all lays. It's a really good article. So I would definitely recommend that. And as I mentioned, the features are very similar. Let me just take a quick. Sorry, 1 second. Oh, okay. So here's an example of what you can do with SVG. Can you recognize what shapes are in there? Basically, ellipses. Then there's some line segments, triangles. Notice the coloring effects. Those are the gradients. And that cloud is a path element that uses multiple arcs to create that. Now, one thing about that checkerboard thing, in SVG, it has one feature that I have not seen even in Silverlight and other comparable technologies. Typically what happens is in SVG you have a G element where you do the circle, ellipse, whatever. You can have multiple adjacent G elements, you can have nested elements. Above that section, the G element, there's a defs element you can define as definitions, and in there you can define your specific linear gradients, your radial gradients, and then compositions thereof. So you could do something like, okay, I want a rectangle, these dimensions, and inside, it's like a template cookie cutter. And there it's going to have this radial gradient pattern or a checkerboard pattern, and then you can refer to that pattern in the fill attribute below some other element. So only SVG does that, which is very, very powerful. The other thing is, whenever you have these G elements, you have an ID. And you can refer to that ID in another G element somewhere else, and you can build this kind of like a hierarchy of objects. And it's extremely powerful because you can have a very complex, sophisticated set of components, if you will, somewhere. And then, if you want to say scale it, all you got to do is Or for another G element, just say that and scale equals 2. And it instantly doubles everything for you, or whatever it is that you want. You can do it individually for the X direction or for the Y direction. If you only specify one value, it applies to both. So the power and the manipulation that's there is unique to SVG, plus the fact that SVG, since it's vector-based, whenever you resize something, it's always sharp. You don't get the jaggies. That's why it's really good for things like AutoCAD. Or, for example, I don't know how extensively it's used. I think a modern 737 has over 1 million parts. And imagine what the 787 has. And the diagrams, keeping them there, I mean, having them legible and so forth. SVG is ideal for that. I don't know the extent to which it's actually used there. You hear a lot more about AutoCAD. But anytime you need really, really good diagrams, that's where SVG's strength is. And that's why I'm kind of showing you sort of the, there's the kind of the very, what would you call it, drawing-oriented, formalized blueprints, right, the not so exciting stuff. But there's also that sort of more artistic side that exists that you can do actually quite easily with SVG. I'll show you a couple more. So here's kind of a cutaway view where there's 3 circles involved basically, plus a gradient shading pattern in the middle. And this is an example of what I was saying about the scaling and so forth. So the main, I just drew this because I wanted to draw a wristwatch. But it's all basically circles, polygons, and all that kind of stuff, shading pattern. So there's the top piece. Now you notice this one down here, it's based on the first one and then just apply the skew in the Y direction and change it. That's it. The one on the right, I think I did a scaling this way, horizontally, maybe 0.8 or something like that. That's an example of what I was saying. And I think I got that one. Is, again, you see the, can you see those 2 little cubes in the front? Left. Those are based on the larger cube, the skew of 0.5. That's it. And finally, another one of those. So I wanted to show you something a little bit different. So these are sort of similar, but let's take a look at this one. So this is a 3D surface. And it's a function of, it's like z equals f of x, y. So in the plane there's x and y, and then there's the z value and plug into the equation. There's I forgot the equation exactly there, but so what happens is you calculate the points, the 3D points, and then you have to map them to 2 dimensions, and it's very simple to do. And the other thing is, how do you get this effect here? If you wanted to do something like this, see the little, they look like sort of rectangles. Well, the idea is, it's a simple one, they're all very similar. You essentially find a little rectangle in the plane. So you have a point x, y. You have a delta x to go slightly to the right and a delta y. And then there's another point that's going to be x plus delta x, y plus delta y. So you have 4 points in the plane. Compute the z values using that surface equation that you have. Then you'll have 4 points in space. Map those 4 points in 3D space to 2D space, connect them as a quadrilateral, and you're done. Then you take that shape, it's sitting in 2D, and you apply whatever colors or gradients or whatever it is that you want. So it's a very simple technique. It's very efficient because you're just drawing a bunch of quadrilaterals, and you can create some fairly sophisticated effects. In order to do this, you can't do it with, I neglected to mention something. There's pure declarative SVG, so it's all straight SVG. It's all XML. Then there's this form of whereby you can use JavaScript. And in an SVG document, you have a C data section, and in that section you have your JavaScript. Now, why would you do that? Because at runtime, you want to perhaps create some elements dynamically. For example, suppose you have a real-time chart of data. How would you How would you do that with a static file? You can't. So you need to have some mechanism whereby you can programmatically create elements and adjust their attributes. So for example, like a rectangle for a bar chart, you get a feed from a server, I'll show you an example, where you're getting values back, maybe it's a stock ticker type thing or whatever. You get those values back, and then in the code you have a mechanism. Now here's a little extra little part that you would have to do. Since the SVG document, there's an HTML page with an embedded SVG document, which in turn has this C data section with JavaScript. The HTML page would invoke something out there. You could use WebSockets, server-side events, Ajax, whatever. That comes back to a JavaScript function. That would then need to, in HTML, that needs to be communicated, and you can do it. There's a little bridge there where you get into the SVG, invoke the appropriate SVG method, which is, the appropriate JavaScript function in the SVG code in the CData section. And that in turn you would use to update the values. So, I mention that because this is not pure SVG. It would be kind of crazy to do that. This is all done programmatically. I think it's about 2 pages of code. And so anytime you get something that's not one of the standard 2D elements, typically that's what you have to do. So there's that, and now that takes care of sort of the SVG stuff and the basic Canvas stuff. Now, you remember at the beginning I mentioned that typically with Canvas element that you write to it, and it's, fire and forget and so forth, and that you can also read from it. So, for example, this is something that actually is, I believe, is done in a much more sophisticated fashion. This is what Photoshop does. You take an image, load it into a web page, and that, since it's a bitmap, it's binary data, it's actually a string of data representing, it's not an actual rectangle, right? Wherever it is on disk, it's stored in some fashion. So once you collect that back, and you're you put that data in an array in memory, what you have is, for each of the pixels in that image, it requires 4 bytes for the colors, because you need one for R, one for G, one for B, and one for the opacity. So if you've got this array with all the data, you can kind of go through a loop, and you can modify the values of R, G, and B. You change the color of the image, right? So for example, I didn't put it in here, the preamble stuff here, but basically, here's a way of getting a weighted sum of those 3 consecutive values, RGB, of 1 pixel. I'm not looking at the opacity here. I'm using this weighted sum. Now those numbers are, I think there's something about our eyes. We have the cones and the rods in our eyes, and I always forget which is which. But for some reason, apparently, we're more sensitized to green than we are to the other primary colors. So as you can see, it's R, G, and B. The G has the largest weight. And then this is second. This is some kind of empirical results. I'm not really sure. So this gives us a sort of a way to smooth out the image that's rendered by recalculating the values of each pixel that's in the image. Okay, everybody with me so far? Okay, so if you, I want to give you an example where here, okay, you can't picture, not the best choice of pictures, but, so what I'm doing, keep your eye on the image on the right. Okay, so this is happening, it's going to get strange looking. But basically what's happening, and I'll show you the fragment of code. Okay, so here's the example. Every time you click, remember that the RGB values have to be integers between 0 and 255. So I'm just using the click count, starting from 0, incrementing by 1 each time you click. And I'm using a factor of 3. just because that way it's not too fast, not too slow, and kind of you see the progression. This is how you calculate the values. Remember, for each pixel, R, G, and B, what I'm doing is taking the current value and adding the factor times the click count, and then at the end, modulo 255 to make sure that it's not, doesn't exceed the maximum value of 255. Remember, this is, everything's positive here, so you don't have to worry about being negative. And so that's why it kind of rotates over, sort of, and they're independent, so the colors get kind of weird. But that's the basic idea. And if you want to, what was I thinking here? I don't remember. Inverting an image, how would you do that? Sort of, whatever is there, take the opposite. That's the formula. So you would take the current R, G, and B values and subtract them from 255, so you get the 255 complement of the color. Or how would you get the sort of the negative color effect, like a negative, you know, there's no color in it? What would you do with that? Not a trick question, but it's not totally trivial obvious. The idea is that you want the grayscale for everything. Now, if you set the R, G, and B values to be the same, there are two extremes. They're all 0, it's black. They're all 255, it's white. What happens when the R, G, B values are all the same and they're in between those two values? What do you have? Some shade of gray, correct? So if you wanted to do the kind of the grayscale version of a particular image, you would go through each pixel, it's not here, you go through each pixel, take the RGB values, add them, divide by 3, take the average, and set the new RGB value to that value. And that gives you your grayscale. So if you want to do something a little bit more sophisticated, and these are some techniques that are used, in the very trivial cases for Photoshop. Essentially what you do is, you know, you have a picture, you've got sort of spiked colors, and you want to kind of smooth that out so the picture is kind of, I don't know, more subdued, I guess. One technique, which is very simple, is to go through the pixels for the image, excluding the border, I'm talking in this case, just to make it simple. Take a 3x3 array around each point. And using the technique that we looked at before, of all those 9 points together, including the center point, take the average of all the R values and set the R value for the middle point equal to that value. Do the same with the green, the average of the green, and the average of the blue. So what does that do? That gives you a contextual, relative, kind of a smoothing, if you will, based on not only the pixel itself, but also its sort of immediate surrounding. Now, once you've done that once, you get sort of one smoothing level. You can do it multiple times, you can continue to smooth. If you want to get even more sophisticated, you can use a 5x5 array. And so you would take the average of all the red, green, and blue. So those are some of the filtering techniques that are used in Adobe and Photoshop and some of the open source projects. Now, I would not recommend that you reinvent the wheel by doing this manually yourself, but this is just an idea, gives you an idea of what you can do if you want to need to manipulate a pixel element. And I think, yeah, we just talked about that. I just found this toolkit yesterday. I haven't used it. There are several of them. Some of them, this one's supposed to be one of the better ones, and it gives you, instead of manipulating like we did manually at the pixel level, there's JavaScript APIs that enable you to modify values of the pixels in a way that's kind of a clear abstraction. Okay, so I mentioned before there's a live feed, and this is actually not, it's using, oops, bear with me one moment. Okay, so this, let me just move this over here. This is an example of using rendering a bar chart in Canvas with real-time data. And I want to just find that for you. Over, one second, I have it running here. just want to show that so you can see it updating. Okay, so right now I have a Python-based WebSocket server. It's an open source project from Google, so it's running on listing on a port. And there are some buttons that you can see down below where this right here, start server, what it does is essentially it sends a message to the WebSocket server to start sending data. And that will send, I'm just using a set of random values, it's simulating a feed from somewhere. And that comes back to the appropriate method in the HTML page with the JavaScript code, and then it updates the values. Now, does anybody work with WebSockets? Okay, I'm going to be talking more about that in the next session, more of the internal details of that. Basically, what WebSockets does for you is provide an alternative to HTTP whereby you have bidirectional, independent, simultaneous data transmission over one TCP socket, so that instead of starting a request each time you want to send and receive data, the highway is open the whole time. So this is actually just receiving data from the WebSocket server. It's not sending anything back. But because it's a WebSocket server, potentially, I can't really think of a good use case for it, really, certainly not with charts. Potentially, you could have something from your HTML page with whatever your graphics are to maybe, issue some kind of request, I guess. Maybe from getting data from another feed, possibly, or another aggregation, something like that. So that gives you an example of what I was talking about before, and finally, I think we'll stop that. And I mentioned before that there are toolkits out there, so if you don't want to work with sort of raw Canvas or with raw SVG, there are some JavaScript-based toolkits that give you a layer of abstraction so that you don't have to get your hands dirty with the actual underlying stuff. The advantage of those is that whenever new versions come out, new functionality comes out, you automatically can derive the benefit from that. And also if there are bugs, obviously, you have to deal with resolving those. One of the Paper.js is a very popular one. There's also Fabric.js and Easel.js. All three of those are JavaScript on top of Canvas. There are others as well. So you do a Google search, you can find a number of them. But those are the ones that I've seen so far. And I want to do this one here. I hope it's not too loud. We'll find out. So this is audio in Canvas. What I found. Where was it? No, it's not. 1 second. It's wait. I'm running a local server to I've got multiple things running. Let me just check. Bear with me 1 moment while I find this. One second, this will be faster this way. Or not. This is not cooperating. may have to skip that part of the demo. I guess I broke something. So what I just wanted to show you was there's a way to access the audio channel in your, like on your PC or laptop. And you can do that in Chrome, and you can also do it in Mozilla. And at this point, you need to use the browser-specific prefixes, you know, for WebKit is -WebKit in CSS3 land, or just WebKit, or MOZ for Mozilla, IE, and so on and so forth. So it's not fully supported uniformly across all the browsers yet, but it will be soon. So you can, I'm not a musician, I don't have the, I just listen to it, I don't construct the stuff, but if you want to see someone who's done some really amazing stuff, his name is Chris Wilson. He's a Googler. He's the W3C co-editor of the, I think it's media specification. He's created, I think I have his link in there. He's created a web page where, in JavaScript, you can drag and drop construction kit style thing where you've got reverbs and filters and, you know, inputs and crossing all over the place, doing all this amazing stuff. And then you can do an input from playing an MPEG-3, or you can do live input. And he's a very hardcore musician and very smart and technical. So what I'm doing is just a sort of a lame overview of, or sample of what you can do. It's not a reflective of the full capacity. So remember that name, Chris Wilson. And since we probably are not going to be doing that demo, basically what I was just doing was following the amplitude of the sound wave and using that to drive the dimensions of a, I think it was a circle and a rectangle to locate it on the screen. And that's very simple to do. I mean, once you get access to the audio input and you get the frequency, the amplitude, and all that kind of stuff, then there's your input. It doesn't really matter where it came from. Then on the graphics side, the canvas, the graphics and animation, then you do whatever it is that you want to do with that. The demo that I really want to show you is the video embedded in Canvas, and someone did something very clever, which I never thought, never even occurred to me that you could do this until I saw it. And when Janine does her magic, I can't believe I just unplug it and all of this happened. So,
That's not working on mine either, so I think it's just a... Go ahead.
So you're saying it's not going to work?
I don't think so. Not in time.
Okay, well, maybe we'll just sort of wrap up early. The slides are going to be online, so the links are there. You can take a look at them at your leisure. Yes, ma'am?
Are there packages that if you're running the graph, it'll transport from pixel space to XY, or?
The one that I showed you, that link, I think it does that. I actually saw it the first time was yesterday, so I don't know how good it is, but I saw it in an article somewhere. I'm guessing it could be one of the better. Yeah.
Oh, so was that Paper.js? Is that what you're talking about now? Or?
No, what she was referring to was the pixel manipulation.
Here.
Yeah.
Oh.
The Paper.js, Easel.js, Fabric.js, those are all JavaScript toolkits that provide a layer of abstraction on top of Canvas. The other...
Can you explain why you or which one you would use and why you would use
Good question. There's no simple yes/no answer for that. It's kind of sort of what you need and the functionality they provide. They're all good. It seems like Easel.js is a little bit more powerful in terms of what it can provide. However, some of the visual effects that I've seen with Paper.js and so forth are very impressive. So if it's more on the artistic side, those probably are better. There are toolkits that are JavaScript based on top of SVG. For some reason, many people don't really want to work with SVG. The one toolkit that I would recommend, which I had on one of the slides, is D3, it's document-driven data. Mike Bostock, he's over at Stanford actually, wrote this toolkit. It's based on an earlier one that he wrote. Very, very impressive what you can do. So if you like JavaScript and you don't like SVG or don't care for it, great toolkit. There are other ones. There's Bonsai, B-O-N-S-A-I, and it's on the slides again. I don't remember which one was there. Raphael is another one too, actually. The nice part about something like D3 is that it supports method chaining. And if you've done jQuery, you're familiar with that. So you can have really compact code. In fact, it can be very, very terse and kind of confusing, actually, because unless you know exactly what it does. So there's a bit of a learning curve to be able to write that really compact, efficient code. But it's worth your while because it's very, very good for data visualization. And the point being that under the cover, it's SVG. So you're getting that real clear, crisp, sharp graphics effects without having to deal with the semantics of SVG. Yes?
So we're interested in using D3. What is your experience in sort of how many points is for talking about 40,000?
How many points?
40,000 points or something like that we're trying to plot?
Yeah.
Typically isn't a lot, but is that a lot for D3 or?
I don't know. You'd have to try it and just to see. You're talking about performance.
Right.
What I would recommend is this, before you start doing that, there may be people who've already done it. If you go to the forum, sign up for the mailing list for D3. It's very, very active. Mike is always there answering questions. And if you post that question there, I'm sure you'll get some, you're going to get some feedback. And Mike would know, so no one else. Is anyone else doing data visualization? What are you using?
I don't know yet. I'm just trying to learn as
Oh,
much
okay.
as possible. But basically, it's going to we're trying to plot a real-time graph of data coming in. So it's something similar to what you had.
Okay.
But I don't know how
Of course.
how quickly we can update.
Right, right. Yeah, the performance, the speed, and so forth, obviously critical. And of course, the capabilities that you provide on the client side. If you're going to take real-time data, a live stream, multiple sources, getting that in a meaningful fashion is a challenge in itself. If you're going to start getting people the ability to kind of move around, mouse, rotate stuff, that obviously, you may not be able to provide all the functionality to all users. And that, of course, we're talking about desktop, laptop. Once you get into, tablets, performance is even more critical. As far as I know, let me see. Everything you've seen today works on a tablet. Android, ice cream sandwich, iPad 3. I don't know the other iOS devices. My iPad 3 is the first iOS device that I've gotten, so all the rest to me I don't know anything about those. But I think that you're likelier to have, this fly is bothering me, you're likelier to have backward support with iOS than you are with Android. I've done some graphics where it worked, CSS3-based graphics, it even worked on an iPod. And on the iPod, it was as fast and clear as on an iPad 2. I was amazed. And the hardware acceleration is vital because it had CSS3 transforms. I was with a friend of mine, we were a Nook color. So trying to see what would happen. It was like, I thought it was broken. So I was sitting on the table, and literally 2 minutes, my friend and I had been talking, 2 minutes later, something moved on the screen. So I guess the takeaway is, if you're going to do graphics and animation and it works on a Nook tablet, it's going to probably work everywhere else. Obviously, there's no hardware acceleration. And if you don't have, you're basically dead if you don't have that for anything beyond the simple, trivial stuff. So, I mean, it really is that vivid. Yes?
This is an ignorant question on my part, but last night a friend of mine asked me at dinner when I thought HTML5 might be able to provide an interface experience for like Flash, and my first thought was that the individual elements that appear on canvas would have to support an on-click event. And as far as I know, the individual elements, if you've got 5 balls or whatever on that canvas, they do not currently support anything like that.
As far as I know, you're correct. So you can, I haven't done much of it, but you can have mouse events. You can detect mouse events on a canvas element. Like you saw the one that I was showing you that was trying to spin stuff around. So that was on the granularity is of the level of the object, meaning the canvas object. And so if you need to have pixel level stuff, basically you're hosed, from what I know so far. So potentially you could do something for example, if it's mobile. jQuery mobile with SVG, and you're going to get a better level of control in terms of the elements and so forth. I mean, it's the trade-off, right? You want everything, but you may have to sacrifice something, so it's kind of case by case. That's definitely a potential issue. That's what you need. I mentioned WebSockets. It's available. It works on iOS 4.2 or higher. It's not available on Android, just in case, just FYI. And so
We need tech support.
we're done early. So now the skill testing
On the book.
question. Yeah, I don't know. I'm not gonna. Do you have a question?
Oh, with the book?
Do you have a question? Skill testing question?
Oh, yeah, I do.
Okay.
Yeah.
I just have those nerdy math arithmetic questions that are really annoying, which is why I like them.
Oh, right. Okay.
If you don't, I have one in mind.
How would you go about getting a negative color effect in an image? It's setting a negative color effect.
How do you get a negative color effect? Do you mean inverting it?
Yeah, inverting it.
How do you invert the color effect? That was on one of the slides.
Yeah.
She was just 2.2 seconds before you. 200 milliseconds, that's all that it is. You are correct. So I will autograph it for free, but you have to tell me what to write, because that's the hardest part for me. I don't know what to say, I hope you enjoyed reading it as much as I enjoyed writing it. That's the only thing I can come up with. It's way too late. So anyway, for the people who were not here at the beginning, I've got things for 3 of my books, stuff, cards, and so forth, if you want to avail yourselves of that. And then tomorrow-ish, I think, I will put the slides online so you can get the links. And I really recommend that you see, I can describe it, the video one, because I just think it's kind of amazing. There's a video that's playing really sharp and clear, and then when you click on it with your mouse, it explodes that section and like a bunch of pieces flying all over the screen. And then a few seconds later, it all kind of reassembles. It's really nice. I mean, that's the effect in total, but not something, again, that you would necessarily use on a production system. But again, just to give you an idea of the capabilities. I don't remember the website who created that. And there are many more effects available as well. One more thing. In addition to Chris Wilson that I mentioned, Scott, sorry I forgot his last name, he works at Yahoo, he's been there 7 years, very heavily into music. He did Sound Manager 2, I believe it's on GitHub. He's, like the scratchy thing that you do with the music, you got the turntable, and he's done all this with CSS3 and I think with SVG Canvas. It looks like a real, like a turntable, and you can do this easy and very sharp. So I'd recommend that. Remember, Sound Manager, do a Google search, and his first name is Scott.
Last name's Schiller.
Yes, that's it, Schiller. Thank you. Yeah, Scott Schiller. And Scott Schiller and Chris Wilson collaborate. So you get the the union of their knowledge. And what time is it?
It's 2:46.
Okay, we just finished right on time with that. So thank you, and enjoy the rest of your day.